In this section, we'll be talking about correlation coefficient, which you apply when you like to test if there is a relationship between two numerical variables. Correlation coefficient ranges from -1 to 1. The number indicates magnitude, which is the strength of the relationship. The further from 0, the larger the strength. And the sign indicates whether the relationship is positive or negative. In other words, 1 doesn't mean a stronger relationship than -1. Rather, 1 means a positive relationship that the two variables increase or decrease at the same time. On the contrary, -1 means a negative relationship that when one of the variables is increasing, the other will be decreasing. The equation shown here is for Pearson's product moment coefficient. The xi and yi indicate the ith value in each of the two variables. And the x and y with a short line on its top indicates the mean of the variable. And the sign that looks like an inverse 3 means to sum up from the first value to the nth value, or we say the last value. Here are some examples of the correlation shown in scatter plot. Each point represents one data point that has two values in two variables respectively. The correlation shown in the top left corner is 0.9, that is close to 1, which is a very strong positive correlation. You can see that the points are close to each other and almost form a line. The plot on its right has a correlation of -0.8, which is strong as well. The plot shows a negative relationship that when the value increases along the horizontal axis, the value on the vertical axis decreases. The plots in the middle are relatively weaker than the top, but still stronger than the ones on the bottom. There is almost no correlation between the variables shown in the bottom three plots. Here is an example of where the correlation coefficient can be used in real world. In this plot, the values on the horizontal axis represent general well-being test scores, and the values on the vertical axis represent the depression test scores. These two variables have a very strong negative correlation of -0.8. Which makes sense since a person suffering from depression will usually have a good health condition. Until here, some of you may be wondering if we could predict the score of one variable from the other since they're so strongly correlated. The answer is yes, we can, as long as these two variables are truly dependent but not accidentally correlated, like the Mexico lemon example we saw earlier. The predicting model is called regression, which you will be learning in the following modules. For your information, in a correlation coefficient test, a p-value can be calculated, but it will not be something we care about most, since even if we have a p-value less than 0.05, which indicates that the correlation found is not by an accident at a 0.05 level, if your correlation equals to like 0.1 or something very close to 0, the results won't be very useful as well. What we want to use to reject the null hypothesis is a strong correlation score as well as a small p-value to prove us the relationship is strong and significant. Okay guys, that's all of the content of this section. Now please answer the following questions.